So, when most of us hear the word chemistry, we instantly picture scientists in crisp white lab coats, right? Bubbling glass tubes, sterile labs, the whole shebang. But honestly, the most fascinating chemistry lab you have access to is probably sitting just a few feet away right now. Yep, it's your kitchen. In today's explainer, we're going to learn how to spot the invisible world of chemical reactions happening right in front of our eyes, and we're going to do it using nothing but everyday household items.
Okay, let's dive right in with what sounds like a totally impossible question. Can you unbake a cake? Seriously, imagine you have this beautiful, fluffiest sponge cake sitting fresh out of the oven. Could you somehow in any way reverse the process to get your original cup of flour, raw eggs, and sugar back? And the answer, of course, is no way. And the reason you can't is actually the foundational rule of what makes a chemical reaction. You haven't just mixed things together here, you fundamentally transform them into something else entirely.
To really grasp this, we need to contrast two very different types of changes, physical and chemical. If you melt an ice cube, you get water, but you can just freeze it again to get the ice back. If you tear a piece of paper, sure, it changes shape, but it's still paper. Those are physical changes because no new substance is made. But a chemical change, like baking that cake or burning a piece of wood, is completely different. Like the famous French chemist Antoine Lavoisier figured out, the total number of atoms remains exactly the same, but their actual bonds break and rearrange. They permanently lock together to form something entirely new.
So the absolutely crucial point here is knowing exactly what to look for to prove this invisible rearrangement of atoms has actually occurred. We obviously can't see atoms with the naked eye, but they do leave behind macroscopic clues. Let's introduce our chemical detectives checklist. There are 5 key sensory indicators that prove a reaction occurred. First, a gas is produced. Second, there's a noticeable new odor. Third, a change in temperature, meaning it gets hot or cold on its own. Fourth, a sudden change of color. And fifth, a precipitate forms.
Let's quickly unpack that heaviest piece of scientific jargon on our list so we know exactly what we're looking at. What on earth is a precipitate? Well, simply put, a precipitate is a new solid or cloudy substance that suddenly forms when 2 completely clear liquid solutions are mixed together. Imagine pouring 2 clear liquids into a glass, and literally instantly the mixture turns cloudy and a solid powder sinks right to the bottom. That brand new solid is your precipitate, and it is a massive, waving red flag that a chemical change just took place.
And that brings us to another really dramatic clue: a sudden color change. Take turmeric, for example. Turmeric contains a chemical called curcumin, which is naturally a bright yellow. But notice what happens when it encounters a basic substance, like a mixture of soap or baking soda. It instantly transforms into this deep, rich red color. It's basically a visual alarm bell telling us the chemical structure has changed. Interestingly enough, if you were to add an acid, like a squeeze of lemon juice, it would actually reverse right back to yellow.
All right, let's move to section 1. The ultimate test with baking soda and vinegar.
Let's see how our checklist applies to the most classic, nostalgic household experiment of all time. For this test, the steps are wonderfully simple. Take a cup, add 1 single teaspoon of standard baking soda, and then pour in a 1/4 cup of white vinegar. As soon as those 2 super common pantry items touch, I want you to play the chemical detective. Based on those 5 clues we just talked about, what exactly are you observing?
Now, what's really interesting here is that we didn't just get 1 clue, we actually got 2 distinct signs of a brand new substance being born. First, there's that incredibly vigorous bubbling and fizzing. That isn't just trapped air escaping, it's the active, real-time creation of carbon dioxide gas. Second, and this is something you'd only notice if you were actually holding the cup, the temperature noticeably drops. The cup feels colder to the touch. This means the reaction is actively absorbing heat from its surroundings to break those atomic bonds. 2 crystal clear indicators that the baking soda and vinegar are gone and a new substance has arrived.
Okay, moving on to section 2, spotting everyday reactions with a rapid-fire quiz. We've laid the groundwork, so let's put your detective skills to the test. I'm going to present you with a few everyday household situations, and I want you to mentally sort them into either a physical change or a chemical change. Ready? Scenario number 1. You slice an apple for a snack, but you get distracted and forget about it. When you come back an hour later, that crisp, white apple flesh has turned a dull, unappetizing brown. Think about your checklist. Are there any clues here? Physical change or chemical? If you guessed chemical, you nailed it. It's a chemical change. The core clue here is that permanent color change. The inside of the apple is reacting directly with the oxygen in the air in a process called oxidation.
It's actively creating a brand new substance right there on the surface of the apple, which gives it that unsightly brown color.
Okay, scenario number 2. This is a very famous internet trick. You drop a Mentos candy into a 2-liter bottle of soda, and suddenly a massive, explosive geyser of foam erupts into the sky. I mean, it absolutely looks like the ultimate chemical reaction. But is it physical or chemical?
Aha, this one is a total trick. It is actually entirely a physical change. I know. We said gas production means a chemical change, but here's the catch. The carbon dioxide gas was already trapped inside the soda by the manufacturer. The rough, porous surface of the candy just provides a place for those existing gas bubbles to gather and rapidly escape the pressure. So no new chemical was formed at all.
Let's try scenario 3. We have all been victims of this incredibly relatable and honestly rather unpleasant kitchen accident. You pull a carton of milk from the back of the fridge, open the cap, and are immediately hit with a terrible, sour smell. Physical or chemical?
Yep, that is absolutely a chemical change. Remember our checklist? A pungent new odor is a prime indicator that the structural composition of the milk has fundamentally changed. The bacteria inside have essentially broken down the sugars and proteins into entirely new, sour-smelling acids.
Scenario 4. You're making some iced tea or lemonade, and you stir a spoonful of solid white sugar into a glass of liquid water. The sugar completely disappears from view. Now, because mixing a solid into a liquid made the solid vanish, does that automatically mean a chemical reaction took place?
Nope, it doesn't. This is a physical change. While the sugar has disappeared to the naked eye, its chemical structure hasn't changed one single bit. The brilliant part is that this is completely reversible. If you were to boil that glass of water until all the liquid evaporated, you'd find your exact original sugar crystal sitting right there at the bottom of the glass.
Here's scenario 5. You leave a shiny, smooth iron nail outside in the dirt for a few weeks. When you finally find it, it's no longer shiny. It's covered in a rough, flaky, reddish-brown crust. What do you think? Physical or chemical?
This is a textbook chemical change right here. We have two massive clues: a very noticeable color change from shiny gray to reddish brown, and a brand new solid has literally formed. That flaky texture is rust, a completely new substance born from the iron reacting with water and oxygen. You definitely can't just wipe that rust off and expect to easily get your original iron back.
All right, final question for our quiz. You're in an art class, and you take a dollop of bright red paint and mix it thoroughly with a dollop of bright blue paint. The resulting puddle is vividly purple. Now, we said earlier that color change is an indicator. So is this physical or chemical? This one is often super confusing, but it is actually a physical change. A true chemical color change requires the atoms to form new bonds, like our turmeric changing red or our apple rotting. With paint, you aren't changing the chemical properties at all. You're just physically blending existing red and blue pigments side by side so your eye magically perceives it as purple. It's just a simple mixture, not a reaction.
Which brings us to section 3, the final clue.
As we wrap up this explainer, I want you to consider this wild thought. Inside your body right now, trillions of cells are taking the food you eat and the oxygen you breathe, breaking those chemical bonds apart, and rearranging them to create the energy that allows you to literally hear my voice. You are experiencing temperature changes, gas exchanges, and new substance formations constantly, every second of the day. So the next time you think chemistry is just something found in a dusty textbook, remember, with every breath you take, you are the ultimate chemical reaction. Keep observing, keep questioning, and I'll catch you in our next explainer.